piled figure for the biasing concept. Now up to this limit we are just understanding the basic operation of the parallel clippers. Now we have to move towards more complicated circuits in which we apply internal batteries, either supports for the conduction of the diode or either not supports for the conduction of the diode. Now comes on the figure 1. This figure shows this is the P terminal for diode, this is the N terminal, this is the positive terminal of the battery. That means this battery opposes the system. That means this battery doesn't want the diode to conduct. That means for again the input is sinusoidal sine wave, positive half from 0 to pi and negative half from pi to 2 pi. So for the positive half direction the polarities are positive here, negative here, which can forward bias the diode. And if the diode is forward biased, that means there must be a conduction of the current. But because this battery doesn't want the diode to conduct, that means there must be a certain voltage across the output terminal from 0 to pi. Because if the diode conducts, then there is a no drop because the resistance of the diode is 0. If drop is 0, the waveform is 0. But up to a limit for which this battery opposes this conduction of the diode, the waveform is appears. So waveform is appears for 0 to V. As well as Vm increases or dominating the V, the waveform is cut down for the positive phase. While for the negative half cycle, positive is here, negative is here. Here we see that here the diode acts as an open switch, and if the diode acts as an open switch, nothing happens, either V is attached or not attached. Vi is directly appears to V0, and we find that the waveform is similarly appears minus of Vm for the negative half cycle. Now what happens if we connect the battery with the different polarity? Here this is the P terminal of the diode, this is the N terminal of the diode, this is the negative terminal of the battery, this is the positive terminal of the battery, and we find that this N is attached with the negative. That means this battery supports the conduction of the diode. So for the positive half direction, the diode wants to conduct as well as battery supports the diode to conduct, and this path is taken by the current as a loop, and because the resistance is 0, the drop is 0 and nothing is appeared from 0 to pi. But something is appears from 0 to pi in the negative phase. Why this is happens? Because for a case, don't consider any input, don't consider any output, replace diode. Now what is across the output? The battery V, which is always there. So battery V is always there from 0 to 2 pi, always from 0 to 2 pi. While in this case battery is also there from 0 to pi, but just after this limit, as battery opposes the conduction, so this voltage overtake this voltage, so the waveform is cut down. Otherwise this must also be up to here if this is supporting in nature. So here battery is supporting in nature, so for the negative half cycle the polarity is changed, the diode acts as a open switch. So is there any addition of the voltage? Battery can add the voltage. Here the concept is quite different from the series clipper. The amplitudes of the diode as well as battery is added. While here there is no question arises, because if the circuit is opened by this switch, then either V is shown or V is not shown. There must be no concept for the adding of the voltage. So only is that for the reverse half cycle the diode is open switch and the path is not here. So Vi is directly appears across V0. So Vi is again appears from here to here. In this way, again I repeat, from here to here. So two waveforms are there, one due to V and another with the diode. So due to V the waveform is here, and due to diode the waveform is here to here. And whatever is the resultant of these two voltages, that means if we superimpose the waveforms obtained by this V and this diode, then we find that from here to here only battery is there, but from pi to 2 pi, this waveform is overtaking the V, which is only superimposed in nature. Now similarly, if you go on through the different portion, that is negative clipper, series clipper, we find that for the positive half cycle, the diode doesn't conduct. And here, because this is the P terminal and this is the negative of the battery doesn't want the diode to conduct. So for the positive half cycle, it acts as a open circuit or open switch. For open switch, it is necessary Vi is directly appears across V node. So a waveform with peak amplitude Vm is appeared across the output. Now for the negative half cycle, this battery opposes the conduction of the diode, as well as diode is also in reverse bias, forward bias condition. For the next case, if negative is here, positive is here, diode wants to conduct and battery opposes the conduction. So the similar concept which is shown here is there. For pi to 2 pi, the waveform is not appeared. Only the difference between the voltages is appeared. Similarly, here the battery supports the system, only the difference is the direction of the diode is changed. So for the positive half cycle, this is open switch, Vi is directly appeared to V node. Where battery supports the system, so batteries also appears for the complete cycle, and the waveform given by this V is this one, while the waveform given by this diode is this one, and the resultant is superimposed of these two figures. So these are the explanation of clipper circuit. Now if we complicated the circuit, then what happens? Now this is the little bit big circuit. Here shows the Vi, the R, the diode with battery V1, this diode is battery with V2, and what is the output? So as we know, the current always follow the path with minimum resistance. So for the positive half nature, with positive here, negative here, this diode is in forward bias, but this battery opposes. Only if we analyze this circuit for the positive half cycle, then this circuit is similar to this circuit. While for the negative half direction, this is open switch, but this is not open switch. So this circuit is similar to this circuit. And for the positive half, this circuit works. For the negative half cycle, this circuit works. Now what is the answer of this circuit? That means if we superimpose this figure onto this figure, we find that here there is a cut after the V volt, and here the complete waveform. So resultant of this waveform and this waveform is this one. While for the negative half phase, complete waveform is shown, but there is a cut. So when we superimpose the common portion of this waveform and this waveform, then we get this one. Either we can consider V1 or V2 equal, or V2 is greater, V1 greater, but here we only consider V1 is greater than V2. Now what happens if we say diode is not ideal in nature? That means you have to specify whether the diode is of silicon or germanium. In that particular case, if the diode is of the silicon, that means we have to take consideration of 0.7 volts. While if the diode is in germanium, then we consider the voltage which is 0.3 volt. And as per the requirement, this voltage is subtracted or added in the wave.